Hello students. So today we will discuss another important reaction, and this one is Rosenmund reduction reaction. One of the most important method for the preparation of the aldehydes. See, in this method what happens here, the acid chlorides based on catalytic hydrogenation, means addition of hydrogen in presence of catalyst. Hydrogenation gives aldehyde. See, actually in this reaction, a partial reduction of the acid chloride occurs. This one, the reaction can be written as, see, this is RCO and Cl. Here it is acid chloride. And now reacts with hydrogen, and in presence of catalyst palladium. Here this palladium acts as catalyst, and BaSO4 is also there, PdBaSO4. The BaSO4 ensures the partial reduction. Here this acts as poison. Now one of the hydrogen replaces the Cl in the form of HCl, and the product is aldehyde. This is the reaction. See, here sometimes what happens here, that if the acid chloride is more reactive, so in that situation sulfur or quinoline or xylene, these are added to reduce the activity of the catalyst, means they are used as a poison in addition to the BaSO4. In case this occurs if the acid chloride is more reactive. Now remember one thing here, how this BaSO4 or these poisons reduces the activity of the palladium. Actually, palladium provides the surface for the adsorption of the reactant molecules, and these poison they occupies the surface of the palladium, and in this way they hinders or they reduces the adsorption of the reactant over its surface, because already poison occupies the surface. One exception is here. With this method, suppose this one is the formaldehyde. So remember, formaldehyde cannot be obtained by this method. We cannot prepare the formaldehyde. Why this cannot be prepared by the Rosenmund reduction? So this is because the acid chloride which we requires to prepare the formaldehyde, that will be formal chloride or methanol chloride. This product, or sorry, this reactant methanol chloride, which is required to obtain the formaldehyde, this one is unstable at room temperature. So therefore, the formaldehyde cannot be obtained by the Rosenmund reduction. Is it clear? Now we'll discuss that how the reaction occurs, means the mechanism of the reaction. See, what happens here in this reaction, the catalyst is palladium, and as a poison here BaSO4 is taken. Or in case the acid chloride is more reactive, so in that case here sulfur or quinoline or xylene are taken. So what happens here? This palladium and the poison, they associates, or you can say that the palladium gets poisoned, means some of the poison molecules, these molecules are acting as poison. This one. So these poison molecules, they reduces or they reduces the surface, they occupy some of the surface area of the palladium catalyst. See, these L, and this forms the catalyst and poison association occurs here. See, here the L, this L stands for the poison. It may be sulfur, quinoline, xylene, and it may be BaSO4 also. So here the catalyst poison association occurs, or you can see that the poison molecule adsorbs over the some of the surface area of palladium. Now this poisoned, here it is poisoned palladium or catalyst. This poison catalyst undergoes oxidative addition with our substrate or reactant molecule, means acid chloride, and forms a addition product here like this, along with, so two of the poison molecule sets free, and here you will get such type of addition product after oxidative addition. Now this addition product, this one is addition product. Now this addition product reacts with the hydrogen, and now hydrogen will replaces these two poison molecule, and we will get this type of substituted product. Here these adsorbed poison molecules, it may be sulfur, it may be quinoline, it may be BaSO4, it may be xylene, these are replaced by the hydrogen. And now finally this substituted product undergoes reductive elimination reaction. Here in elimination reaction, we know that some smaller, simpler molecule is replaced, and the two atoms which are replaced may be from the same atom or maybe from the two adjacent atoms. So here the H and Cl, this sets free. That's why it is known as elimination reaction. And now the electrons of this CPD bond shifted over the palladium, and at the same time the hydrogen shifted over the carbonyl carbon along with its electron pair. See, as the hydrogen will come here, the palladium will get electron deficient, the two electrons will shift over palladium. Now the palladium will set free and the hydrogen will come over electropositive carbon, and we will get our end product or desired product, aldehyde. So this was the mechanism of the reaction. Is it clear?